Hey everybody, welcome. This is your Nature Journal Educators Forum, and today we've got a very interesting topic. I want to explore the next generation science standards with all of you, and I want to explain just a little bit about what they are and how they work, and why I think it's really useful, but also initially a little bit confusing. But if you are not an educator in the United States, or if you are not an educator who is in a state that is using or has adopted the next generation science standards, I think you're going to still find that this is useful. Rebecca, hey, welcome back. It's great to see you. I just saw that you're there. Welcome. We missed you. I'm really happy to see you again. So this workshop is going to be in two parts. First, I just wanted to lead by just doing a little presentation of what I think is kind of really useful to know about and how I think about it, and how I use it. And then we're going to go into a discussion between all of us about what we think is interesting, relevant, useful, your thoughts about that, your thoughts about that as well. We also want to hear from Billy Joe about how your discussion with Beth Ann went, and give you an opportunity to share about that. Actually, let's start with just, well, a few more people are logging in, just with some group announcements. Let's also hear from Billy Joe about the interview. Evea, could you lead us with just some kind of community announcements?
Sure thing. Okay, so tonight, if people are interested, Marley Pfeiffer is having his Nature Journal show, and it's about choosing bags in the field. He'll be having one on Sunday about habitat restoration at 1 o'clock. So please join us. I'll be hosting a live chat because he's currently in Vermont. Let's see here. Tomorrow we get to have round number 1 with Jack of Oh My Gouache, in case people want to learn about gouache, because I learned from the best about puns. And let's see here. Also tomorrow morning, 9 o'clock in the morning, Pencil Miles and Chill, everybody is welcome. Also, congratulations to Ray Bonto for going to level 2 in judo, which is like awesome. So congratulations, Ray Bonto. Saturday, I think Brian says that he's not going to be having class, but double check with him if you're curious. Sunday, I think Melinda's not having class either, but check their calendars. Melinda's got excitement coming up. And last announcement, next week, be here, because we get to learn about the VTS, the visual thinking strategies, near and dear to Jack's heart and beginning to be near and dear to mine. And with that, I hand it over to Billy Joe. And then also Rebecca has announcements too.
Okay. So yeah, just want to plug the VTS thing. I'm bringing these visual thinking strategies people in for a presentation. They're going to walk us through a visual thinking strategies experience. I believe that this is hands down the best way to do arts education, and if and be there. I think you're going to really, I can't overhype it enough. This will rock your world. With that, Billy Joe.
Hi, everyone. I'm hoping my internet is good. I'm back at the centers. Thank you for the shout out. I had a lot of fun with Beth Ann. Yeah, it was just such a wonderful experience. She's amazing. And so I reached out to how it all happened. I reached out on Instagram to ask her if we could link some of her blogs and websites to our website that I shared last week. And she immediately was like, I don't know you, but I know you from the internet. And I know that these sessions are videotaped, but I in my world just think people don't watch them. No one knows who I am. And anyways, that's how it happened. And we just had the best time. And we had to cut it off at an hour and 24 minutes. And then we talked for about another half an hour after that. So she is just incredible. So if you haven't been listening to her podcast, I highly recommend it. She's had on some truly amazing and inspiring people, and it's a wonderful podcast. And her voice is just one that I could listen to forever. So I was very honored. We had a great time, and thank you for anybody who listens, because it was really, really fun.
I'm really delighted that you had a chance to talk with her. You are such a vibrant part of this community, and advocate and innovator. Really delighted to be doing this with you.
Yeah, it's spiraled. So people started listening to it, and now I've been invited to do a couple of talks for school conferences and things like that. So who knows where this rabbit hole of awesomeness will take us. So yeah, so it's been great. I'm gonna continue to Nature Journal and just have a lot of fun. This community is so amazing that you can't just not be a part of it once you're in. So it was pretty awesome. Thank you so much, everybody.
That's cool. I'm going to just write down, that's my Billy Joe quote for the day: the rabbit hole of awesomeness. Rabbit hole of, yeah. Going down these rabbit holes, the world just opens up. Curiouser and curiouser. Great. Well, thank you. So what I'm going to be doing is, so I know you're in Canada, but this is still, I think, going to be relevant, because I think that the next generation science standards are, there's built into it some crazy good, useful ideas. So if you're a homeschool teacher, or you're teaching up in Canada, and you're not beholden to standards that have been developed by a district somewhere, still pay attention to this, because this is going to be really, really cool. So I'm going to start just with a PowerPoint presentation, except I'm using Keynote. And so here is my, here we go. This is, yeah, I'm gonna wear my heart on my sleeve. I think it really rocks. And here's why I think it is so cool, and why we should play with it. So if you, in the past, next generation science standards, what we had, at least in the United States, was a long list of things that by this grade you should have memorized. And there's a little nod to practices of science, that people were going to learn the scientific method, and then they would be scientists. The only problem was that it didn't work out that way. Is when we got people into sort of applied careers in it, or in a setting where we needed to hire scientists for people to do science. These people, we had created a system that was very easy to test, and because and actually the testing drove a whole bunch of the content. We taught things in ways that were easy to test, so we could test those things, and we came up with this really elaborate testing system. And when we got people into careers, or at the university level where we needed them to perform as a scientist, they were completely unable to do that given the training that they had. So we would get people through school, they would have really good scores in science, but they had absolutely no idea how to function as a scientist. So this was a problem. And it was a problem within the sciences, and also at the sort of industry level, that you couldn't just if you hired somebody, you then had to train them how to be a scientist. So the idea started to get passed around is, what if when we're teaching people how to, science in school, what if we taught them the skills that they would need to know in order to be functional as a scientist? And this seemed like a really, really good idea. So a bunch of people got together. So first paragraph here, the team that was assembled for this. So this is the National Academy of Science, the National Academy of Engineering, National Academy of Medicine, or actually I think it's Institute of Medicine, or maybe it's Institute of Engineers. One of those in an institute, the others are the academies. National Association of Science Teachers, so people with some chops on how do you teach science, and the American Association for the Advancement of Science. I love my spelling. So that was the crew that was brought together in developing this. There were Nobel laureates, there were like a bunch of people sat down, and they spent years and years and years and years doing this. And it went through lots of different iterations. And what they came up with at the other end was the next generation science standards. And I think it really paid off. There are some really useful ideas in this that you can apply whether or not you have to teach with the next generation science standards or not. If you do have to, I think you're lucky because you get to. And this system has been widely adopted across the United States. Many states have just the whole thing, taken it and used it. Some states have made a modification to that because it explicitly references evolution and it explicitly references climate change. And because of political nuance in our country, those were taken out by some state legislatures, but the rest of the system more adopted. There's a few states, Texas, Florida, places like that, that have not really been influenced by it. But most of the places in the United States are using something where we kind of really see the impact of NGSS. So if you're designing a curriculum and it works with these ideas of the next generation science standards, you're going to find that lots of people in the United States are going to be able to use what you are doing. You've put it in a form that will be useful to them. Let's take a look at what that form is. In the past, the structure of what we're doing was mostly, let's memorize all this information. And then again, there was a little nod to this thing called the scientific method. The only problem with the scientific method, and we've discussed this before and will probably be a discussion for a future workshop, is that the scientific method is not the method of scientists. Scientists aren't out there using the scientific method. Scientific method is used extensively by science teachers, but not by scientists. All the things in the scientific method, the different activities, are things that scientists actually do, and they have use and utility. But that little story that's told by, this is the method that you do this and this and this and this and this and this, really adds a ton of confusion and gets people actually thinking in some wrong ways about how to do science. So that's a kind of a topic for another day. But let's take a look at what the next generation science standards is. They came up with this little Mobius strip visual aid, and what you're seeing is they have the idea, there's three different aspects of the next generation science standards. They are all equally important, and they are they're tied together. The first part, these practices, the science and engineering practices, these are the things that scientists do. So some of those are, aspects of what we used to call the scientific method, like asking questions. Asking questions is something that scientists do. We develop experiments. We analyze data. We discuss our ideas with each other and all these sorts of things. So those are the things that scientists do, and they have done for generations. And using those practices, they have been able to figure out a bunch of stuff. So that brings us to the second thing over here in orange, these core ideas, what they call the disciplinary core ideas. Think of this as, here's stuff that scientists have figured out using the science and engineering practices. So there is some basic science information, stuff which we have learned that is useful and practical for functioning adults and kids to know about. So there still is content within the next generation science standards. It used to be 99% this content. Now it's 1/3. And so they are saying that you don't have to teach as many of these sort of different ideas, but what you are going to teach, we want you to do it better and go deeper. So there is permission granted within the next generation science standards to teach less and to teach it better. The third thing, what they call the cross-cutting concepts. This is, how do scientists think? What are, and it turns out we don't just have a bunch of kind of like a big pile of leaves of ideas. There's actually kind of sort of forms of our thinking. There are some key ideas in the sciences that you are just going to keep running into again and again and again and again and again. And once you realize that there are some of these big ideas, that allows kind of the nucleus of a sort of a core understanding of big picture ideas. And then what you can do is you can tie little facts to that. So this kind of gives us structure in our thinking. So I think of these as what do scientists do? What have scientists learned? And then how do scientists think? Let's take a look at the practices themselves. Yep, let's go back there. Right, here it is, science and engineering practices. So this is, on the left, is a list of the science and engineering practices. And I'm going to ask everybody to take a look at this. And I'd like you to think about this in terms of, hey, nature journaling. When you're nature journaling, which of these do you engage with when you are doing nature journaling? Let's take a look at this list. Or perhaps an easier way of expressing this is, or discussing this, are there any of these science and engineering practices that we don't really engage with when we're nature journaling? If so, I'd be curious to find out what those are. Spoiler alert. And so if there are any that we don't really think that we're connecting with, just maybe drop a note into the chat saying, you know, what those might be. Right now I'm looking at the chat and there are crickets. It's still silent in the chat. So people aren't putting anything in the chat right now. So my sense is that we actually, these are all things which can regularly get wrapped into our nature journaling practice. Our whole, I notice, I wonder, it reminds me of, I wonder, we're asking questions, defining problems. If when we're making explanations from what we're doing, like, well, could it be this? How would I figure this out? As we're kind of mapping those out in our journals, we are creating models. We are also creating simpler models to sort of help us understand physical objects when we're sort of diagramming plant parts and things like that. We mentioned carrying out investigations. We have our 3 language: words, pictures, and numbers. With those numbers, we are looking for the ways of quantifying what we're doing. And then we want to figure out how can we analyze that data that we collect. So we're trying to figure things out about the world around us by by our physical observations of that world. And all those processes can go down into our nature journal. This idea of engaging in an argument from evidence, I think is huge, is really, really important. The idea of the argument from evidence is that we're going to say, I think that this is going on and here's why. So we're looking at the natural world around us is our evidence. So when we're trying to figure out how things work, we're looking to that. So the journal is where we document all of that information. And then as we are communicating this information with other people, so sharing our journals or having discussions with other people, the journal itself can be a useful tool in that. But also, as we're nature journaling, we are also training ourselves to think and communicate visually. And this makes us much better science communicators. So my sense is that every one of these science and engineering practices, nature journaling is a part of that. So when you're doing nature journaling, you're already doing 1/3 of the next generation science standards. Let's take a look at the other 2/3. So the idea of the disciplinary core ideas, these are the little, the bits of information, the facts about the world that we might want to be a kind of science literate person. You would have, you had been exposed to, there are, and not just exposed to the ideas, but exposed to the evidence behind those ideas and those explanations. So not just be able to parrot to somebody why I think the germ theory of disease is better than the method of curing disease by balancing the 4 humors, but what the evidence for that is. The specific details of which little bits of information in the life sciences, earth, space sciences, physical sciences, they've worked that out all by grade level. At this grade level, you're doing this. At this grade level, you're going to be doing this. With that part of the next generation science standards, I think there are a bazillion ways that it could have been done. And they chose the way that they did. And that's fine. This is part that I don't have that strong an opinion about, because they just sort of chose, like, let's use these teaching ideas. I think I would have done more nature observation and woven that throughout the whole thing. But hey, I wasn't at the table. But but at the end of the day, you're going to end up with a sort of a useful set of kind of functional skills. Again, I don't really get that wrapped around the particulars of, at this grade level, you should be, this is where you were learning about the Earth's place in the solar system or the universe. But they've come up with their system. So the final part are what are called the cross-cutting concepts. And I think that this is probably the least understood of these 3 parts. So let's just sort of take a look at what those cross-cutting concepts are. This is a little visual that I made. So these are posters that I made of the different cross-cutting concepts. So if you're a teacher and you want to have posters of cross-cutting concepts in your classroom, you can go to my website, you can print these out. They come in several different sizes and several different styles. So for instance, there is a style that just has them with these gray tone things. There's another that is just black and white line art in case you and your students want to color them yourselves. What I recommend people do is just sort of put these up as posters in your room. And over time, if you come up with a better thing, would be a better poster for one of these, that your students make that and then replace it. And eventually you'll have all student made one. So basically you're sitting around and you're kind of looking at these big ideas. Okay, there's cause and effect, there's structure and function. Like, these are ideas that we've heard before, and some of them are a little bit more intuitive than others, like cause and effect and structure and function. Everybody knows what I'm talking about. When I start saying scale, proportion, and quantity, there'll be some people who are going like, well, what exactly are you meaning here, right? When you're talking about, stability and change, like, oh, okay, I think I know what you're talking about, but So these are, some of them need, I think, a little bit more unpacking. But again, they're just they're useful ideas, big picture ideas in that you're going to bump into again and again and again in science. And so what the way we kind of gain facility with these is by just in our processes of talking about and engaging with other sorts of things, we can have a discussion about this plant that we're looking at based on sort of the ideas of structure and function. Like, let's take a look at this through think of these as different lenses. If you could put up a little lens to your eye, you're going to look at the same plant through the structure and function lens. That's going to change the sorts of questions that you ask. Then if you were putting up a stability and change, like really like, how is this changing? What was it before? What will it be next? Those sorts of questions are going to be a whole different line of questioning than you would get if you were to be thinking about systems or relationships between things. In looking at these, something I think is a little bit confusing about them, people have sort of started to kind of look at, how do they relate to each other? And we run into what scientists call the demarcation problem. The edge of one of these ideas kind of feeds into others. So for instance, the idea of cause and effect, isn't structure and function due to cause and effect? So is structure and function then a subcategory of cause and effect? So people have come up with some different ways of kind of subcategorizing these, and there's a lot of sort of discussion about this online. I found these two kind of ways that people have kind of broken them out into sort of separate thinking. So there's this one on the left is one way of thinking about it. The one on the right is another way of thinking about it. Where the one on the left, they say like the big thing here, like basically anytime you're looking at anything in the physical world, everything is going to relate to cause and effect. So within that, there are patterns that are, when you see pattern, those patterns are there because there's some sort of mechanism behind that pattern, right? And you're seeing the effect. The pattern is the effect. What is the cause of that pattern? And similar structure and function, there's those also is clearly kind of a subcategory of cause and effect. As they kind of get down further into this, there's sort of people are making arguments that matter and energy is a subcategory of structure and function, and systems, scale, change and stability, these are kind of subcategories of patterns. Some people in thinking about these find this structure really useful. For me, as I'm looking at it, I'm kind of going like I get your kind of cause and effect, pattern, structure, and function. As I get kind of lowered down, it seems to me that we're sort of making some leaps here and wanting everything to fit into a neat diagram. The one on the right is another way other people have thought about it. They sort of break these things out into patterns, causality, and systems. And they have, patterns goes into pattern one, cause and effect and structure and function go into the cause and causality one. And they're saying that these other ones are sort of more related to systems. So for instance, how does you think of the differences between matter and energy? Energy flows through a system. Matter cycles inside of a system. By the way, if anybody ever talks to you about the energy cycle, they're missing the point. There's no energy cycle. Energy flows through a system. Matter cycles within a system. And so, those, I can see how that attaches to the idea of systems. Stability and change. Okay, that makes sense to me also. That is this a stable system? Is this a dynamically changing system? or is it just a system that is changing very slowly? Probably many systems people would say there really aren't any stable systems in nature, but things may just be at a rate of change that is not as great. System models, of course, should be in there. Scale, proportion, and quantity. Yeah, does it really go in there? That's number one. You know, we could agree or disagree about that. Maybe they just had needed a place to put that. I might have stuck that up with patterns. I don't know. But all of this goes to say is that thinking about these concepts and how they fit together, I don't think there's yet sort of a one right way to think about them or kind of subcategorize them. But just be aware that the relationships between these things, the relationships between them, and the kind of they will flow into one another. And sometimes you'll find yourself having a discussion about systems, and you're talking about matter and energy. So there's a lot of ties in and relationships between them. So this then ends up with a lot of people going, how on earth do I then use these cross-cutting concepts? Well, I'm glad you asked. Oh yeah, this is something that I found online. People are saying, like, you know, that basically when you're doing NGSS, they say that you should be doing all of these three things together at the same time. So you should be doing science and engineering practices that are investigating one of these core ideas, and then you're going to be analyzing that through the lens of one or more of these cross-cutting concepts. And so there's like, these people have made this website that basically kind of gets people drawing lines between this, like, I'm doing this idea, I'm going to tie it to this and to this, and then I'm going to loop that into this. For me, a lot of this seems like overthinking it. I want to show you what Emily and I did in our book on how to teach nature journaling. This is an activity that we wrote up in our How to Teach Nature Journaling book. And what we're doing is you're picking out here in this activity two objects, so this leaf and this leaf. And then on your page, you are going to be comparing those two and thinking about how they are similar and different from each other. And so in doing this, you are initially going to be using a number of different science and engineering practices to get yourself observing and thinking about this. You're then going to have these on your piece of paper, and at the end of that activity, you're going to, what Emily and I are suggesting that you do is that y'all sit down together with your students and you talk about what you just did. You have students share with each other, I found this, it was like this one, this was different in this way. And we talk about that. And what we've done in the discussions is broken them down to a set of questions that you could prompt students with if you were having a conversation about different cross-cutting concepts. So notice that these subcategories here under discussion, each one of those is a cross-cutting concept. We suggest that you have a conversation about one of these, not all of these. It'd be way too long a conversation. But after you've done this comparison between these things, is that you could sit down with each other. You could then, from the perspective of structure and function, discuss these two leaves. And how is it different than the other one? Why do you think that how might that difference, what might be a function behind that? How might these function differently? So you could have this structure and function conversation after doing this. And so what you're going to do then is you're going to take this concrete experience that everybody's had doing the activity with the leaves. Everybody in the class now has a personal experience with looking at these. And so when you're asking questions, This will be something where more people in your group can participate in the conversation because we all kind of have this, so there's sort of a common experience that we're all bringing to this. You can have that conversation. Here we're suggesting patterns or cause and effect or structure and function. And we find that it's in these discussions at the end of the activities that a lot of the real insights and meaning making that can come out of doing nature journaling will emerge. So I used to, when I started teaching nature journaling activities, I would present the activity, then the students would do the activity, and then I would say, well done, and move on down the trail. And what I was missing out on is that every time you do one of these activities, there's a golden opportunity for deeper meaning making in discussion with each other. And so I want to encourage y'all to think about in your nature journaling activities, how can you bring in some of these discussions on these rich topics? This part ends up being incredibly fun. As a teacher, I was missing out on one of the most fun aspects of this whole process. It's not just doing the nature journaling. No longer think of the discussion that you have at the end. I used to think of it as a wrap-up or a wrap-up discussion. Now I think of it as the discussion, as a core central part of the activity where you get to engage with these different ideas. At the back of our book, we go activity by activity, and we break down, here are science and engineering practices that you would be engaging with by doing this activity. Here are cross-cutting concepts that could connect with, and those cross-cutting concepts tie into the discussion prompts which we provide. And here are some disciplinary core ideas that would also lead directly to that. We find that with those tools, you are in a good place for being able to engage your students with this. So for me, how are the science and engineering practices being brought in? They're being brought in because you are now doing science. By doing journaling, you are doing so you are participating in the practices by not just reading about something. You're actually you're being a maker, right? How are the cross-cutting concepts tied in? Those are tied in through the dynamic conversation that we get to lead with our students at the end of the activity. Again, no longer thinking of that as a wrap-up, thinking of this as this is like the discussion. Oh, good, I get to have that discussion, right? And then, if I am not too particular about the science and engineering practices or the disciplinary core ideas, the individual subject matter nuggets of information that you're imparting. You could be doing this around looking at rocks, and that can tie into lessons on geology. You could be doing this on lessons, dissecting a flower and tying this into lessons on botany. All the rest of the structure still ties in there. So you can, for the actual kind of the information content pieces, that can be specific to your needs. But those other pieces, the science and engineering practices and the cross-cutting concept pieces, are coming in and clicking in and engaging with whatever activity you're doing. So that is my spiel on NGSS and why I think it is really, really cool. And again, I think it's turning us, we're trying to be, not just sort of make ourselves consumers of science, but we want the kids to be makers. And so this is that transition from consumer to maker. And that's the end of my presentation. And check that out. We still have some time for a discussion. So love to hear. I'm now bouncing over. I'm going to remove my spotlight, end of the John Muir Laws monologue. And I would love to hear from y'all. I know there's also a lot of folks here with tons of experience with this, or there may be some people, also some people here with like where their experience kind of comes in from a surprising direction. So how is this resonating with you? Thoughts, ideas, and comments? Catherine. Hi there.
Hi. I wanted to know if I can share my screen.
Yes. Hold on a second. I am going to make you. There's probably a better way to do this, but I'm going to make you a co-host.
Oh,
right. You are now Catherine, the co-host.
All right. I'm driving. All right. I'm going to share this. This might be an example of overthinking, but I'm a big fan of graphic organizers. And I've been trying to get my head around the NGSS for years. And so the only way I could think of to do it was to see it all in one place. And I guess my focus in this was kind of understanding the DCIs in life science, earth science, and physical science. And then you can't read everything, but it kind of breaks it down into the core components, and then also like what grade level objectives and how they fit in. So I'm still working on it, and I know it's a little crazy, but I just thought I'd show it and see what people think.
Can you explain to us a little bit about this the structure that we're seeing here?
This is it's a structure called an Apollonian gasket, and it's kind of a fractal idea based on self-similarity and how it's kind of like cells, like how nature manages to fill every space in a beneficial way. I don't know. It's just since my focus is art and trying to figure out all this science stuff through an artist lens, I kind of like this way of organizing the information.
That is really interesting.
Yeah. So
maybe zoom in on some of this for us.
Hold on, now it's still being made, but so in the life sciences, it's broken down into 4 main ideas. So one is structure and processes, then there's ecosystems, and then inheritance of traits, and then this is the evolutionary one. And then within each one of those, it's broken down into other sort of, like you were saying, nuggets.
Oh, this is interesting. I see where you're going.
Because I teach multiple grade levels, so I kind of have to see it, from the whole like K through 6 or K through 5.
That's cool. Could I show you a similar diagram that I think is also very useful?
Sure. I'll do stop share.
Okay. I think it's interesting that you showed that. Let's take a look at this. This is a Venn diagram that somebody made of the overlap between the science standards, the math standards, and the language arts.
Yeah, I've seen that before.
And this I find also just sort of a really useful idea, where you realize that anytime that you are kind of making arguments from evidence and looking at trying to do problem solving based around evidence, you are engaging math standards, science standards, and English language standards. Your diagram just sort of reminded me of this Venn diagram. I find this Venn diagram very freeing because it helps me to sort of see the overlap between these different things and realize that when you're teaching, anytime you're doing something engaging in that argument from evidence, that you're also actually teaching across disciplines. I find that useful and reassuring.
Yeah, I love the interdisciplinarity of it all. And I think that makes it so much more meaningful to me as a person that has an inherent fear of science. That just kind of helps me fit it in to the world.
Right. Thank you, Catherine. And thank you for sharing that diagram.
Sure.
I'd love to see as that develops,
Yeah.
what happens with it. And then we get to add color.
I do have a color version, but it's super hard to read.
Oh, okay.
Yeah.
Billy Joe, I saw your hand was open up a moment ago.
I just was, I have my science curriculum here for grade 1 to 8 in Ontario. And so it kind of like the States, each province has their own curriculum. But I thought it was interesting listening to the NGSS and then looking at my own curriculum and seeing that we like have science, but then science is split up into life systems. It's split up into understanding structures and mechanisms is another unit. Understanding matter and energy is a separate unit, and then earth and science spaces. So I thought that was interesting because those are some of your cross-cutting concepts as well, but we separate them into different science strands. And so, and then patterning and stuff is actually in our math curriculum, because math is then split into 4 different parts as well. So there's like number sense, algebra and patterning, data management, different things like that. So it's just interesting to look at the different curriculums between the 2 countries. But I had some grade 3 teachers the other day asking how they could incorporate nature journaling into their life science unit. And in grade 3, life science is plants specifically. So all things sort of plants. And so grade 1 and grade 2, they were looking at growth and changes and adaptations. And then they finally get into like looking at like the parts and stuff like that. But I said to them, like, you can look for, like, you can build math into that with your patterning. And then structures for grade 3 is strong and stable structures. So they could be doing that at the same time as looking at their plants. So trying to get teachers to look at it is not like I am teaching this science unit and then this science unit, that they can take plants, for instance, as a common theme that runs through the whole thing, because by the time Earth and space systems get around in grade 3, that's soils. Well, you can't have one without the other. So really getting them to think in a different way, and how nature journaling can sort of bridge the gap between all of those. And then, you know, grade 4 is habitats, but you can be talking about, like, if the kids are talking and that comes out in that sharing piece, well, then to me, they're just getting ready for grade 4, right? Like in terms of adding that extra layer onto it. So I just thought it was interesting. So if anyone here is in Ontario or Canada, I think, you know, it's not the same as the NGSS, but we have it's a little bit similar. I found once I started listening to this and then looking at ours, it's just set up a little bit differently. But yeah, anyways, I just wanted to share that because I thought it was kind of interesting.
That's a I'm going to join you here on the screen. Hi. The the idea that our let's just you mentioned the something on kind of connections or ecosystems, the habitat, habitat.
Sure.
So like I think in the next generation science standards, that would be kind of under the umbrella of, you know, systems and system models. So an idea that you could kind of dig into and play with in what they're doing, encouraging people to do is to sort of play with that idea at multiple grade levels.
Yeah. And I think that's what I'm saying to them as well, is that, like, you can't learn, you know, just about plants in grade 3 without really looking at their habitats. So even though there's a focus on habitats in grade 4, you know, and that's what I said to the teachers, like, it doesn't really matter if you're introducing the concept of what a habitat is in grade 3 or grade 1 or kindergarten. I said they're just going to learn maybe some more specifics about it. But that's where I thought those cross-cutting concepts and the way that our curriculum is done, like, it's very fluid. So I know some people were you know, you had your two charts and people were like, this needs to go with this and this. I think it really depends on what you're looking at, depends on how it's going to sort of flow together, because one might be more cause and effect, one might be more structure based, but I don't think there's a right and wrong answer to sort of how that can kind of flow together. And so I kind of like the one you just showed where you had the language and the math and the science and where they're sort of overlapping, because that's how I'm presenting nature journaling as well, in that you're learning writing, it's in the nature journal, you're learning math, there it is. And so, you know, it's a flow between all those pieces instead of being like, this is the unit we're looking at. I just feel like it's a deeper, more enriching experience for the kids if you show that structure and function and cause and effect is absolutely, you know, can be discussed when looking at botany and plants, or, you know, whatever. So I just thought that was an interesting for anybody in Canada. It's not the same, but it is similar, that you can definitely take what's being done in the US and definitely think about the concepts in a way that you can flow and have that same teaching
And something
up
that
here in Canada as well.
did there, just as you're discussing this and mentioning the flow, you're doing this with your hand, and it's interesting that you did that, because something that I kind of think about as a with a cross-cutting concept, if I kind of think of, I visualize them as a whale,
Yeah.
right? And it's coming down,
Yeah.
and then it's coming back up, and it's going to surface and blow, and then you're going to see it again, and then you're going to see it further up the beach, you know, sort of in a different context. And so sort of seeing how these ideas sort of tie through different experiences that you're having at different grade levels and with different
And I
subjects.
think, you know, like, even if we go back to the basics of words, pictures, and numbers, and we talk about, you know, students maybe, you know, they're not great drawers, so a little bit nervous about that, so maybe they put a little bit more focus on their words and their numbers. You know, math is something that most kids are pretty scared about, right? It's like, oh, I'm not great at math. But if you could introduce math concepts into a way in nature that they are visualizing it and seeing it, I think you'd get more buy-in. I mean, I would for sure if I was that kid. If someone said, okay, we're doing graphing, and I'm like, ah, it's scary. But then they said, you're going to go out and do this, and you're going to collect all that information that you gathered, and then you're going to put it into that, or you're going to look at the patterning in the weather, you're going to look at the patterning in the plants, and then we're going to put that into the concept of learning what patterns are, you know, through math. I just think that you can't do one without the other. So I don't know. We'll see what happens this year as I approach this with teachers and students. But I just think it's so much more enriching to have all those pieces connected together. So, and I think that's what the science standards are doing, right? Like,
That's right.
embedding them
That's
together.
the goal. That's the goal. That there's so like teach this over here in this grade, teach this over here in this grade. Like where you do what they call their disciplinary core ideas. Like I said, I don't care if you do that in third grade or fourth grade. I think studying astronomy is cool, right?
I think if it comes up, you can't just be like, well, we can't discuss that. That's not till grade 4. No, we just discuss it. And
but these big ideas, you want to be reinforcing those concepts, and these skills, we want to be developing our skill set. So we want to be growing with both of those fronts through as these little kind of, you know, instead of like the whack-a-mole of like, you know, the subjects popping up, like, and you're trying to, like, you know, hit this.
Yeah.
I mean, that can be going on, but then if there's these big whales that are swimming through the whole matrix of it, right?
That you can then say to the kids, like, remember when we were outside and we were doing that, and then we're going to bring it back and we're going to connect it to here, and then be like, oh, I see, you know, and there's light bulbs. And if they're, you know, they say structure and function, they make their own bird nest, whatever. You as a teacher just go like, we're going to put those in the classroom on display because they're going to come in handy later when we're doing something else. And you've connected that through there, and it's become a 1 year, you know, timeline. And then kids can see that like structure and function is not separate from this, which isn't separate from math, which isn't separate from language, there is that full connection between all the parts, right? Yeah, so I just thought it was an interesting, as I was listening to you, and I was like, oh, wait a minute, let me pull up my own curriculum and take a look. So I just thought there was some really interesting ways to look at it. So thanks for that.
So that's great. Oh, and thank you so much for that. And so, you know, just my general advice is I don't get wrapped around the axle about which specific subject topic area I'm teaching when. Like, you know, we could have a discussion and a disagreement, and it would be very polite and civil about, you know, whether 3rd grade or 4th grade or 5th grade is the better time to do astronomy. I don't know. But these big ideas, what I want to suggest to everybody is that we get comfortable with some of these large concepts, these cross-cutting concepts, and then that's the discussion that weaves through multiple events, and the skills themselves of how do we ask questions, how do we collect evidence, how do we look at those sort of things, those science and engineering practices. We're always working at that. So those are rolling along. I think a lot of people just because it used to be that you just had to pay so much attention to the like, you know, what topic are you teaching? And it was about, like, you know, I'm teaching about rocks, right? But now, like, there's these how you do it and how you think about it have equal weight to that. So you get that going on in your program, and you have 2/3 of all the science expectations in your pocket. Any other thoughts, comments, or ideas that people wanted to share on this topic? Aisha, good to see you.
So I missed a little bit there, but just sharing for the heck of it, just a random case study from my school where we were doing NGSS the last few years, and we were fusing it with the IB concepts, had overlap, but not always. And it was kind of me leading that, because I seemed to be the only one who'd had a science degree and went to NGSS trainings and was kind of motivated. But it was fun. But I realized that a lot of our teachers, this was K-5, right? So you don't have specialist science teachers at that age. They have to teach everything. And they were most intimidated by the models piece. And so it was actually really fun, because after going to my trainings at Cal Academy of Sciences, I was just like, all this drawing and labeling we're doing, it's models, people, as long as you use it intentionally for that, you know. And when I was always acting out stuff, like Marsha was sharing in the chat, we were always acting out how our water came from Hetch Hetchy and the melting snow and the dams and the rivers and all that. I was like, this is all models. It's a kinetic model using our bodies as opposed to an illustrated model. But it really helped me understand my own program through a different lens. I'm like, I'm doing it, but now I understand that during this unit, I am actually addressing models along with asking questions or whatever. The other thing I wanted to add in was, I was putting this in the chat too, was what really came to mind while we're talking about this. I feel like a similarity that could be useful was when you were talking about, you know, things can't be neatly categorized, and there's all this discussion about should it be subcategories, One of the things that IB requires in its 8 concepts is when you're teaching, say, a core idea, your unit, you decide what are the 2 or 3 concepts you're going to really bring out. Could be structure and function and change, or it could be structure and function and quantization, or maybe you're like, you know, and so you always, as the teacher, have those in the back of your mind, even if the other 6 could be brought in. But anytime a conversation is going too far that way, you're kind of like, we need to come back this way just because we want to get deeper in that, right? So you have a little bit of control. And I was like realizing like that idea with the NGSS cross-cutting concepts would be really nice too. And I could see teaching something and going, I'm going to choose systems and maybe causation because I really want to look at it through that lens for this unit, right? Or I'm going to choose these two because for my brain, those two connect. Because I'm realizing for every scientist is probably connecting things in different ways because they just see it, you know, in different ways. If everything for them is about matter and energy, that's going to be their umbrella. I was like, for me, it ends up being systems and patterns. So that was, that's, I think, all I wanted to share.
Yeah, so I'm going to tie into that idea. I wasn't looking away because I wasn't interested. I wanted just to sort of to tie into what you're saying. This idea of kind of thinking of it as like, yeah, you cannot do, like, don't try to do all the cross-cutting concepts or anything like that. And every once in a while, just sort of entertain another interesting one. The lens that you hold up to your eye will change the color of the questions that you ask, the way that you think. If you were to put down that lens and put up a different filter, you would be thinking about things in a different way, and they're all good. This is the book Island Africa by Jonathan Kingdon. And actually, I'm just going to drop over to a, hold on. I'm beach balling. Can you still hear me? All right. It looks like my screen has frozen up. Let me try this. So this is a very interesting book. It is written by this Wolverine-looking character here, who is a nature journaler and also a mammologist and evolutionary biologist. And his, as he discusses things, his lens, as he looks through the world, he's looking at the world through the lens of an evolutionary biologist. So this is, if you look at, you're looking at sort of life, and we've also got to just sort of check out some of this guy's visualizations of sort of system visualizations. I mean, this is, there's just, isn't that fun? Right, just sort of thinking about sort of visual signaling in mandrills, and that's how he describes it. Oh, that's just that's visual communication working for me. But what he's saying is that, you know, this book, if you kind of read through this book, this is what the world looks like when I kind of look at it through this lens. You look at it through a different lens and you're going to be noticing different sorts of things. But as an evolutionary biologist, this is how he's, oh, this is my favorite map. This is a map of these different flowers. And then on the map, they're keyed to the drawings over here by the color pattern in them. Isn't that crazy? Did you see what's going on with that? I mean, oh, that's
incredible. Look at that.
Isn't that some cool thinking? So like this one here is in this area here. I mean, sorry, this one here is in this area here. This one here with a little scoop. I mean, that one there is that one there. Isn't that fun?
Wonderful.
Right, but so this is the world as seen through that lens.
Yep.
And you can think of those cross-cutting concepts as these different sorts of lenses that you could then hold up to your eye. And the so you know, the cross-cutting concept of stability and change also encompasses thinking about evolutionary processes. And so he would be over there. This is sort of a subcategory of the stability and change lens that he's then holding up to his eye. The other thing that you made me think about is when you mentioned the international school system.
Oh, the IB.
The IB. So this is I just sort of found this in a different lecture that I had made. These are kind of question queues that are used in IB classrooms that are absolutely brilliant, absolutely brilliant. And the amount of crossover with those and the cross-cutting concepts is also really interesting. So the people who came up with this list were really thinking along the lines of a lot of the same sort of big picture ideas. And I think that also people who are not doing, everybody who's not doing IB school can also benefit from adding, these three also question prompts. What are the different points of view on this? How do I know? What is the evidence for that? And what is my responsibility to this, to their questioning about things? I mean, that also just adds this other wonderful layer of depth into what folks in your school system are thinking about. But there's just a tremendous amount of crossover with those cross-cutting concepts. All right. Thank you so much, Aisha.
Mm-hmm.
Well, my friends, that is an introduction to the next generation science standards. I think it is really useful. And realize that, if you're doing nature journaling, you're already doing like a whole bunch of this. And nature journaling just fits so beautifully into the framework, the description as presented by the next generation science standards. And I guess that since there aren't any other comments or questions, this wraps our discussion for the day. But now I would like to, Rebecca, you've got so there's something you wanted to share with the group?
If there's time, I don't want to take too much time, but there are a couple things.
Absolutely. I'm going to remove my spotlight here, and the floor is yours.
Okay. So I just want to give a couple updates. I know I've been gone for a little while. I was working at a summer camp. So I put a hold on writing workshop Wednesdays for the last couple months because I just did not have the time or energy to do it. I would like to start doing it again soon, but probably not every week. So the community calendar needs to be updated. It's not correct, so I'm sorry for the confusion that's been causing.
Do you need help updating that?
I might need a little help. I need to re-find my login information,
Okay.
but I think I should be able to do it. But I'm also teaching.
If you need any help with that, let me know, and I'm there to back you up. Okay. Okay.
Second thing, I am teaching a new course coming up later this month, which is called Nature Journaling for Ecological Restoration. So it's going to be kind of a mix of ecology and storytelling and connecting to the land around you and connecting to community. So I'm really excited about that. And I put a survey. I have a Google form in the chat if anybody wants to. I just have a quick question on there. I'm asking for people's top 1 or 2 questions so that I can make sure I include everything in the course that people want to know. And third thing, a few months ago, I submitted a proposal for the NJEF conference. That's the North American Association for Environmental Education. And I just found out that it got accepted. And for an on-demand session, not a live session, but so it's a panel discussion. The topic is supporting neurodivergent students and educators in environmental education. And I hope you don't mind if I say this, but it's mostly because of Jack and other people in this community that I really started to think deeply about these topics. And so if anyone is into that or would want to be on the panel or knows anybody, let me know, because I didn't get that much notice from when I need to submit it. So I have one educator who wants to be on the panel, and looking for probably about 3 more. I'm going to be the panel moderator. So
I would love to help if you would like me to be a part of it. I think there's also some, but I think a number of people have heard my voice on things in other formats. It would also be wonderful to get some other folks from this community to share their perspectives and voices on it. But I'm happy to be part of that if you wish.
well, I would love for you to be if you want to be, and anybody else who wants to be, just let me know. We can try to organize something.
Congratulations on that. That's terrific.
Thank you.
All right. Are there any other announcements in the community? Things that people wanted to share? And Rebecca, it's really great to have you back. Let's see. All right, with that, my friends, it's time for lunch. It's really good to see you all, and take care of each other. Take care of yourself and take care of this planet. We've got a lot to do, but we can do this together. Thank you all.
Thank you. Bye.
Bye-bye.
See you
Bye,
tomorrow.
thank you.
You, Jack.
See you tomorrow.
See you tomorrow.